Hello friends, continuing with the chapter Charges and Fields. Today we take up third topic, electric field. Previously we have studied first topic, frictional electricity, second topic, Coulomb's law, and now we take up third topic, electric field of this chapter. Now what is electric field? How we define electric field? Region of influence of an electric charge around it. Region of influence of an electric charge around it is defined as electric field. So look at the diagram. Here is plus Q, positive charge Q, and these dotted lines show the field region around it. Okay, so this is the region of influence. So region of influence of an electric charge around it is defined as electric field. Now question arises, what is the strength of electric field? How we measure the strength of electric field? Now let us see. Strength of electric field is measured by the term electric field intensity. Strength of electric field is measured by the term electric field intensity. Now how we define electric field intensity? Now definition of electric field intensity. How we define it? Let us see. Electrostatic force experienced by a unit positive charge placed at a point in an electric field is defined as electric field intensity at that point in electric field. I repeat, electrostatic force experienced by a unit positive charge placed at a point in electric field is defined as electric field intensity at that point in electric field. So mathematically, it is expressed as E vector equal to F vector divided by Q naught, limit Q naught approaches 0, where Q naught is unit positive charge, where Q naught is a unit positive charge or test charge. Now look at the diagram. Here is a plus Q, any charge placed in any region of space. Let P be the point at which electric field intensity is to be determined. What we do, we place a test charge Q naught at this point, and what is the force experienced by this test charge is electric field intensity at point P. Okay, so mathematically expressed as E equal to F by Q naught, limit Q naught approaches 0, where Q naught is a unit positive charge or test charge. Now Q naught approaches 0 means Q naught, value of Q naught should be as small as possible, because if it would have a bigger value, then it will have its own electric field. So it will modify the individual electric field, original electric field. Okay, so Q naught must be very, very small, approaching to 0 as far as possible. Now what is the SI unit of electric field intensity? SI unit is newtons per coulomb, because it is F divided by Q, therefore it is newtons per coulomb. Now type of quantity, it is a vector quantity, because F is a vector quantity, Q naught is a scalar quantity. Any vector divided by a scalar is vector quantity. Now direction. Direction is always from positive to negative. Direction is always from positive to negative. Okay, so whenever we represent electric field diagrammatically, we represented by directed line segment from positive to negative side. Okay, now we come to the term unit positive charge or test charge. Let us become familiar with unit positive charge or test charge. First we give definition of unit positive charge. The positive charge whose magnitude is 1 coulomb is defined as a unit positive charge or a test charge, and its value should be very small, as I previously told you, because if it would have a bigger value, then it will have its own electric field which will modify the original electric field under measurement. So it must have a very small value approaching 0. Now assignment 1.3, third topic, assignment first chapter, third topic first chapter, therefore assignment 1.3. Question number 1. Why a test charge should assume least possible value? Why a test charge should assume least possible value? Here is the reason given for it. You can read it. If it does not assume least possible value, it would generate its own electric field and would modify the field under measurement. Hence, it must have minimum possible value. Now, we try to understand uniform electric field. Okay. So first we take up definition of uniform electric field. If electric field intensity at every point in electric field is constant, that is in magnitude and direction, the electric field is said to be uniform. I repeat, if electric field intensity at every point in electric field is constant, that is in magnitude as well as direction, then the electric field is said to be uniform. Now, how we represent electric field diagrammatically? It is represented by equally spaced parallel directed line segments extending from positive to negative. This is how we represent uniform electric field. I repeat, it is represented by equally spaced parallel directed line segments from positive to negative. Okay. Now we come to non-uniform electric field. How we define non-uniform electric field, then we'll talk of its representation. Now first we take up definition. If electric field intensity at every point in the electric field varies, either in magnitude or in direction or in both, then the electric field is said to be non-uniform. I repeat, if electric field intensity at every point in the electric field varies, the electric field is said to be non-uniform or heterogeneous electric field. Uniform homogeneous, non-uniform heterogeneous. Now representation of non-uniform electric field. It is represented by unequally spaced directed line segments extending from positive to negative. Here is the case, one case. Okay, there is another case. You can see in diagram. This is another case. Electric field, non-uniform electric field, represented by directed line segments. There is equal spacing, no equal spacing. So between the lines, directed line segments, spacing is different at different points. Okay, this is how we represent non-uniform electric field. Now close spacing. Where is close spacing, there is strong field region, and where is large spacing, there is weak field region. Okay, here you can see there is close spacing and here is large spacing. So here field is strong, here field is weak. This is how we can say. Now here spacing is large, here spacing is weak, very close. So in large spacing field is weak, in close spacing field is strong. Okay. remember these points because they are going to help us in understanding electric field lines and other things. Now we come to significance of studying electric field. What is the significance of studying electric field? Study of electric field is an alternative study of Coulomb's law because it is electrostatic force experienced per unit positive charge. That is, it gives the rate of force experienced. Okay, so it is nothing but alternative study of Coulomb's law. Now assignment 1.3, question number 2. Find the electric force on a proton placed in an electric field of 2 into 10 raised to power 4 Newton per Coulomb directed along positive x-axis. Question number 3. Figure shows tracks of 3 charged particles in a uniform electric field. Give the sign of 3 charges. Which particle has the highest charge to mass ratio? I repeat, question number 3. Figure shows tracks of 3 charged particles in a uniform electric field. Give the sign of 3 charges. Which particle has the highest charge to mass ratio? So you have to solve this problem. You can look into your textbook. There you can find the answers. Okay. Now we come to electric field intensity due to a point electric charge at a distance r from it. First we develop physical situation. Consider a point electric charge plus q. This is plus q lying in any region of space as shown. Let P be any point at a distance r from plus q where electric field intensity is to be determined. Place a test charge q naught at point P. Okay. Now the force experienced by test charge, say F equal to K naught Q naught Q by R square away from Q, because plus Q is the original charge and Q naught is also plus, therefore force will be repulsive. The direction will be away from Q naught. Now or we can write F by Q naught limit Q naught approaches 0 equal to K naught Q by R square, or E vector E is equal to K naught Q by R square along QP directed away from P. Okay, along QP directed away from P would be the direction of this electric field. Now we come to discussion points. Now since electric field is given by the expression E is equal to K naught Q by R square. Now when R approaches infinity, electric field becomes 0. When R becomes half, electric field becomes 4 times. When R becomes double, electric field becomes 1/4. Now when charge is placed in a medium of absolute permittivity epsilon A, then EA is equal to Ka into Q by R square, or K naught by epsilon R into Q by R square, because K is equal to 1 by 4 pi epsilon naught epsilon R, and 1 by 4 pi epsilon naught is K naught. Or we can write K naught Q by R square as E naught. So EA is equal to E naught by epsilon R. Okay, the field when the charge is placed into a medium of absolute permittivity epsilon A, then electric field reduces by a factor equal to 1 by epsilon R, or it is equal to dielectric constant of the medium, where epsilon R is the dielectric constant of the medium. Okay, thus force in medium reduces by a factor equal to dielectric constant of the medium. Now, nature of field due to positive point electric charge. Now, electric field originates from positive charge and terminates at negative charge, which lies at infinity. As you can see in the diagram, electric field lines are originating from positive charge and terminating at negative charge, which lies at infinity. The magnitude of the field is E equal to K naught Q by R square, directed away from the charge. Third, electric field is spherically symmetric and is radially directed outward. Now we come to nature of electric field due to a negative point electric charge. Again the similar 3 points. First, electric field originates from positive charge which lies at infinity and terminates at negative charge itself. Here you see the field lines are coming from infinity and terminating at negative point electric charge. Now second, magnitude is given by the expression E is equal to K naught Q by R square, directed towards the charge. Here you can see the field lines are directed towards the charge. The third point, electric field is spherically symmetric and is radially directed inward. So you can look into the diagram that the field lines are radially directed inward. Now assignment 1.3 continues. Question number 4. Find magnitude of electric field intensity at a distance of 0.1 meter from a point electric charge of 0.02 microcoulomb. Question number 5. Where does the electric field due to positive point electric charge terminates? Question number 6. Where from the electric field originates which terminates at negative charge? Okay, these are some questions you have to answer on the basis of the text that you have learned. Okay. Now, thank you so much. Tomorrow we'll take up second part of this topic. Thank you once again.